Solutions for perfect problem 5 for Math 243. We're going to be calculating some probabilities. We're going to be using Normalcdf and inverse norm. The difference here is we're talking about sampling distribution, specifically a sampling distribution of a proportion. So when you read through these problems, you want to pick out key pieces of information. So what we have here is it says, suppose that 32% of all 18 to 25-year-old Oregon females watched at least one Blazers playoff game this year. Fine, whatever. All I care about is this number. This is my population. The word all is kind of a key there. Proportion. And the symbol we have for that is P, or rho, and it is equal to 0.32. Really, there's only, well, let's read through the rest of it. First, it says determine/justify the shape, center, and spread of the sampling distribution of the proportion of 121 randomly selected people from this population. So from the population, I'm going to randomly select 121 of them. That'll be my sample size. And for that, we use the letter N. So in this case, N is equal to 121. And it turns out with these two pieces of information, you know everything you need to know about our distribution. So for our distribution, we want to state the shape, the center, and the spread. That's not how you spell spread. Spread. The shape of this distribution, I mean, you can kind of cheat. In this class, we really only study a distribution that's approximately normal. So it's probably going to end up being the answer. I mean, it is. But why? The reason why is we have this criteria that says that anytime n times p times 1 minus p is greater than or equal to 10. So let's see, n times p times 1 minus p, maybe I should calculate that to make sure it works out. N was 121. P, we figured out was 0.32. And 1 minus 0.32, in other words 0.68, if you multiply those all together, I cannot do that in my head. That's what calculators are for, I suppose. You multiply the three of those together and you get 26 point something. You get 26-ish. 0.33, I guess. Note that 26.33 is greater than or equal to 10. Oh, I'm good. It's approximately normal. Okay. What about the center? The center, we're going to use the symbol mu sub p hat. A complicated looking symbol. All that's saying is every sample, I'll have a different proportion. P hat is the sample proportion. Every one will be different. On average, the average of all these different proportions, I'd expect it to just be the same as the population proportion. Population proportion was given to me as 32% in the problem, so that's what my center is. Spread. Every one of those sample proportions, I mean, they could be different. They'll vary. There's some variance in there. Well, what's the standard deviation? There's a formula for it. Turns out it's given if you just know P and N by this formula. So I can come over here to my calculator and I can say the square root of P, which was equal to 0.32, times 1 minus P, which is 0.68, divided by the square root of N, oh, sorry, that's not true, divided by N, which is 121. The square root of this thing is equal to this number, 0.0424. Weird looking numbers. Okay, what this is saying is that my center is at 32% and my standard deviation is 4.25%, roughly speaking. So with this information, I can answer any question, A, B, or C here. Now let's go through and do it. For A, it says determine the probability. Determine the probability is a big hint there. It means that we're going to be using, man, that's hard to draw. We're going to be using Normalcdf. Shape, approximately normal. I know that the shape's approximately normal, so I'll draw something that's approximately normal. It's hard to draw on the computer. Center, 32%. You put a 0.32 or 32%, whichever you prefer. And then the spread is 4.25%. You could count up by 3 standard deviations, but that seems like a lot of work, so I'm going to leave it as that. and see what the question is asking. Determine the probability that in this sample, more than 30%, so the probability that p hat, the sample proportion, is greater than 30%. Wants me to figure this out. Well, 32% is right here, so 30% is somewhere out here. And if I have to be greater than 30%, I'm talking about this area in here. So this area is the probability that p hat is greater than 0.30, and we can get that on our calculator by using the Normalcdf function. When you use Normalcdf, you have to give it a lower bound, which in this case is 0.30, an upper bound, which we don't have, so we'll use E99 as my upper bound, a mean is 32%, and a standard deviation, which is this guy, I'll just write it, which is the square root of 0.32 times 0.68 divided by 121. Now figure out this probability. You type all that into a calculator. Under the distribution menu, the second option is Normalcdf, and then my lower bound was 0.30. My upper bound was E99. My mean was 0.32. And my standard deviation was, in order to get it exact, I'm going to retype in all that mess. 0.32 times 0.68 divided by 121. Normalcdf, lower bound, upper bound, mean, standard deviation. Hit enter, it'll give me this probability, 0.68. So what's going on here is if I get a sample of 121 Oregon females between the age of 18 and 25, I don't know what proportion of them will have watched a Blazers game. I have no idea. My best guess is that it would be 32%, but I don't know, it could be 29%, it could be 35%. The probability that it's 30% or larger, 68%. Then we do that 2 more times. A little overkill maybe, but whatever. So this was A. Maybe for B I'll switch to green. I believe B is very similar. The only difference is now we want to know the probability that we're between 28 and 31%. Same thing, same picture, same function. 32 still in the middle, except now it's not above 30, it's between 28 and 31. I don't know, 28 somewhere out here, 31 somewhere over here. Doesn't have to be drawn to scale. I want to calculate, I want to calculate this area right here. Well, you do that very similar to what we just did. This is the you don't have to write this part. This is the probability that p hat is somewhere between 28% and 31%. It's larger than this one, but smaller than this one. And the way we calculate that is using Normalcdf. The inputs are similar to above, except now my lower bound is 0.28 and my upper bound is 0.31. And then my mean and standard deviation are the same as they've been. Plug that all into a calculator and I'll get the answer. Instead of retyping all that, I'm going to do a little trick, hit second and then enter to pull up the last entry. And now instead of between 0.3 and that thing, I want between 0.28 and 0.31. Get that right? 0.28 to 0.31. My mean is still 0.32. My standard deviation is still the same. I hit enter and it tells me that that probability is 0.2340. In other words, 23.4%. That's B. B might be a little unnecessary, but what are you going to do? C. Oh, I don't know where C is going to go. This looks like a good spot. Maybe I do it in green so that they don't all run into each other. All right, for C, it says there's some proportion out there. I don't know what it is. But it's so small that there's only a 4% chance that our sample proportion will be less than it. So there's something way the hell over here. My middle is still 32%. Still approximately normal. There's some value out here. I don't know what it is. that gives me this probability, 0.04 here. And I can figure that out. Kind of have to work backwards. I want to figure out what value goes right here. And the way I figure that out is using inverse norm. Maybe I'll call that P naught and say that P naught is equal to inverse norm. With inverse norm, you have to give it 3 arguments. The area below, in this case, that area below was given to be 0.04. The mean, which again, still 0.32. And the standard deviation, still this mess, 0.32 times 0.68 divided by 121, square root of that. You type all that into a calculator. Really, the only thing new you need to know is that inverse norm is the third function under the distribution menu. 0.04, comma, 0.32, comma, that mess. Square root of 0.32 times 0.68 divided by 121. All look right? Looks good to me. Hit enter, you get this number. You get 0.2458. So what's that mean? What that means is every sample, is going to have a different proportion, right? I don't know what my sample proportion will be. I expect it to be 32% is my sample proportion, but I don't know what it will be. But I do know that only 4% of the time the sample proportion will be less than 24.58%. That's what that tells me. This is the answer right here, and I guess that ends this problem.